Everybody say every dirty thing that comes to your head. Get on the mic.
Problem 14 has us doing something we haven't had to do yet. And that thing we haven't had to do yet is, instead of taking things and making them smaller, expand something. We have the identity that tells us that 1 plus tan squared is secant squared. If I subtract a 1 from both sides, I get that tan squared is secant squared minus 1. So I can replace this tangent squared with secant squared minus 1.
That's funny.
Now, one thing I probably should have said before I started all this, I cannot just add these up. Can't just turn that into secant squared. Because to add those up, I would need a common denominator. And I don't have a common denominator yet, so I can't just add those up. But I did my secant squared substitution. This secant squared theta minus 1 can factor to become secant theta minus 1 times secant theta plus 1. Like this. Then my secant theta plus 1s cancel. This is equal to secant theta minus 1 plus 1, which is secant theta. That was problem 14 on your homework. You could have tried to make these cosines and sines, like turn this into 1 over cosine and turn this into sine squared over cosine squared. And that can work. It's very, very long and arduous, but it can work. But this is the way to go. Any question there?
So that was just to substitute as a substitution?
That was, this stuff over here was just so that I could substitute.
Okay.
That was all just for substitution. That was 14 on your worksheet. The last problem on your worksheet. Uh-huh.
Are you gonna ask me one problem or not?
I'm thinking about it. Sure, give me one.
13.
Okay, what was 13?
Sine x cosine x over 1 minus cosine squared x.
I hate the x thing.
We change this to
I'm just
theta.
making thetas.
I did.
Okay. I can just change those x into thetas, doesn't matter. Well, let's see. 1 minus cosine squared is sine squared. And Joe, maybe I'm not sure what you're missing here, but one sine can cancel one sine. You get cosine over sine, and that's cotan. Okay. Yeah. 1 minus cosine squared is sine squared. When you put your name on your worksheet and pass it forward. This. Today we will talk about verifying the truth of identities. Oh, let's get that. Verifying an identity. Which is basically simplifying, only it's nicer because you have a goal. You know what you're shooting for. Just like how your homework last night was nice because you had the answers.
Yeah.
You know where you want to end. That's what's nice about this. Now the confusing thing, what people think they can do and they can't. What you can't do is the same thing to both sides of an equation. I can't multiply both sides by 1 minus cosine theta. I can't do the same thing to both sides of an equation. I'll explain why on Tuesday. I'll explain it now, you wouldn't quite understand it. On Tuesday I'll explain why, but just trust me, you can only manipulate 1/2 of the equation at a time. I can't do the same thing to both sides of an equation. So I'm going to take one side and try and make it look like the other side. You want to start with the left side, make the left side look like the right side, or do you want to make the right side look like the left side?
Left side.
How come?
Because the right side is just one, it's one factor.
Sure.
Final step.
The left side has more to work with, I think is kind of what you're saying.
Yeah.
Yeah, the left side has more to work with, and that's fine. Well, where should we start?
The 1 minus cosine.
What about 1 minus cosine?
Pretty sure that's something.
It's not anything.
Okay.
If it was cosine squared, it would be something, but it's not.
Well, if we change this part,
Mm-hmm.
so what we did
Sine squared is 1 minus cosine squared.
No, that's what I was getting at.
remember something.
Oh,
I can't cancel anything here, and I can't do anything here yet. I can factor it. How does it factor?
Just something like plus or minus 1.
1 minus cosine theta, 1 plus cosine theta.
Oh, now.
And then
Now we can cancel things. We get our 1 plus cosine theta, and that's what we wanted. 1 plus cosine theta.
That's beautiful.
It's the same thing, nothing new.
so what we were doing before was simplifying,
Mm-hmm.
and now we're there.
Verifying that this actually does equal this. We can't assume they equal each other to start, which is part of why I can't do the same thing to both sides of the equation. I don't actually know if they equal each other. I'm trying to show that they do equal each other.
So you never solve these because.
No, we will solve on Tuesday, but not today.
So could you just do like the opposite rule for like the backwards process from the end to the beginning onto the right side?
Mhm.
Just like the same.
Mm-hmm.
Then like, wouldn't that mean that you were just kind of fabricating your own stuff?
Mm-hmm. So that's all we're doing. We're multiplying by 1. It's fabricating stuff. We're just taking stuff and making new stuff out of it and rearranging the stuff to get new stuff.
Okay.
What you also could have done, this is just me doing the same problem a different way, is I could have multiplied by 1 minus cosine theta on both sides to get a common denominator. I'm sorry, by both sides I mean top and bottom. I'm multiplying by 1 to get a common denominator, and that would give me 1 minus cosine squared over 1 minus cosine, and 1 minus cosine squared is sine squared, and this is the same as this. And what Kayla was just saying is if I take these green steps and start here and do them backwards, it's the same thing. I do the same thing as one backwards of the other. And sometimes knowing where to start or where to finish is more obvious depending on which half you're working with. Okay, what should I do with the next one?
We'll just turn them into sines and cosines.
You want to do the left side or the right side?
Let's do the right side.
Okay, why the right side?
It's not negative.
Okay.
And then multiplying.
And the multiplying is nice. We like canceling with multiplying.
Yeah. Which
That turns into cosine to the 4th of theta over sine squared.
can that turn into any sort of cotangent thing, even though it's a 4 over 2?
I've already got the cotangent here. We just left cotangent.
Oh,
But yes, it can. We just had it already. Yeah?
Did you also factor first?
Factor what?
Because
On the left side or the right side? Yeah, there's nothing to factor out of here unless I want to make this cosine over sine first. We can do that. Let's talk about the right side for a second. From here, at this point, I don't really know where to go. But that doesn't mean this was a waste. Because now what's happened is I have 3 more targets to shoot for on the left side. If I can make the left side look like any of these 3 things, then I can make the left side look like that. So if you do one side, you don't get anywhere, it's not a waste. It just gives you more things to shoot for. Okay, so you should erase very, very little in these activities. Erasing is not what you want to do. You want to just try something else. So let's take the left side. Let's turn the left side into cosine squared over sine squared. And my pen gets thicker every time I switch to a new color. Cosine squared over sine squared minus cosine squared over 1. I could factor a cosine squared out of the top, but I don't think that helps me at all.
Wait, that's the same as the other one.
No, times and minus are different.
Oh, that's a minus.
Common denominators. So I'll multiply by sine over sine. Sine squared over sine squared. now I have cosine squared theta minus cosine squared theta sine squared theta over sine squared theta. Okay, now what?
Factor out.
Now factoring is going to be helpful. It might have been helpful before, but it definitely is now. Cosine squared of 1 minus sine squared over sine squared. What is 1 minus sine squared?
Cosine squared. Wow.
Cosine.
And so now I could take this and turn it into this. Then I could turn this and work my way backwards and get back to there. But at this point I've really got it, because this right here is a cotangent. Cotangent squared. So now I have cotan squared cosine squared. And that's what I want.
So you have to make it look like the
The one you
original.
started with. But if I make it look like this, just a few steps backwards to get to there.
To go backwards, you multiply by sine squared.
No, I would literally copy down these exact expressions to go backwards.
Oh,
I would say cosine to the fourth over sine squared. And I would take cosine to the fourth and make it cosine squared over sine squared times cosine squared over 1.
oh, so you're just
And that is cotan squared cosine squared.
Got it.
Alright, you okay so far? Yeah?
I have a question. I understand the cosine squared theta. I understand that one. What's the next one?
This is an identity that gives me this.
Let me redo those two.
These got multiplied to give us. Oh no, they didn't. Then I got a thing from there. Oh. So you're okay to this part here?
The cosine squared.
Cosine squared, cosine squared, sine squared.
Yeah.
Cosine squared over sine squared is cotangent squared. I would call these two problems medium. The next three I would call easy. Right? These should be fairly straightforward for us. Yeah.
Is there going to be a question where it's like,
No, they'll always be identities. They'll never be false.
I mean, not like a question, but like a problem where it's like it has the two set equal to each other, and it'll say, are these really equal, and you have to like solve it.
Yeah, that's really what we're doing right now.
Yeah.
Yeah. The book, when they show it, when they show their steps, the book writes little question marks up here. Because they're saying, are these equal? I don't know. That's basically what we're doing. We just don't bother writing the little question mark. We're trying to show that these are equal. Cotangent is cosine over sine. Cosecant is 1 over sine. Multiply by the reciprocal. And you get cosine. So let's cancel.
That's it.
Fairly straightforward. The next one's a little less straightforward. You want to start on the right side or on the left side?
Up.
How come?
I know.
Okay. What should I do?
Cosine over sine.
Cotan is cosine over sine.
Oh, the whole thing.
Just one cosine.
Oh, here's the
You get one.
No, I know. And I don't get one for like 16 reasons. One of them is that I can't add these up because they're not like term or common denominators.
Okay, you know, sometimes when you see the plus sign and you like.
The second reason, almost equally as important, is these aren't squares.
Well, I forgot that the.
Oh, you thought it was multiply, not times?
Yeah.
Got it.
you
Okay, I'll
see
set that.
two and you're
Got
just
it.
Thinking that you do that.
Got it. It's multiply, not times. Okay.
Yeah,
So what do we do?
You mean addition?
Right.
Common
It's
denominator.
we need a common denominator. So this needs to have a cosine. This needs to have a sine. And now we have.
Now you can get one
Now we can get one somewhere.
on the top.
Cosine squared plus sine squared over sine cosine or cosine sine. Cosine squared plus sine squared is 1. 1 over cosine is secant, 1 over sine is cosecant. That's what we wanted. Because I could take this and I could turn it into this. This expression is the same as this. Okay, third one.
Let's do the right side.
Start with the right side, okay. And then what'd you say, Katie?
I said, well, the plus sign you can make after the plus sign. It can be sine theta times 1 over sine.
And what's sine times 1 over sine?
Well,
So now we have cosecant equals cotan plus 1, cotan squared plus 1, is cosecant squared. Didn't actually need to write this over here. You want to write this over here.
How do you know cotan squared plus 1 is cosecant?
totally.
It's one of our 3 pi tags.
Oh, that's right.
In my other classes, what they did was this. My other classes went like this. Cosine squared over sine squared plus sine times 1 over sine, and that gave us cosine squared over sine squared plus 1. And then here, they wanted to get a common denominator. But just because we went from cotangent to cosines and sines, doesn't mean we're stuck here. We can go right back to cotangent and just sort of do what's easier. Okay, so sometimes you'll change things and realize you didn't need to change them and just go back. You gotta get really fluid and really free thinking with what you want to do where.
Because of the identity.
Because of the identities you're looking for. Doing it by finding a common denominator here would have worked just fine. It's just like 2 extra steps we don't need. Okay. This looks miserable. It's really not.
It's fun.
Cotan x, sin x, cosine x, tan x, secant x, cosecant x.
Can't you cancel stuff?
Yeah.
Right.
I don't have to change. Cotangent times tangent is 1. Sine times cosecant is 1. Cosine times secant is 1. This just equals 1.
Beautiful thing.
I'm doing this to show how the reciprocals work. Okay? Look for reciprocals being multiplied. Cotangent times tangent is 1. If we'd written this out, if we'd broken it down into its sines and cosines, we would have cosine over sine times cosine times sine over cosine times 1 over cosine times 1 over sine. And then we would have gone cancel, cancel, cancel. Oh, I canceled somewhere wrong. Hold on, do it again. Then we would have gone cosines cancel, 1 on top, 1 on bottom. Sines cancel, 1 on top, 1 on bottom. Cosines cancel, 1 on top, 1 on bottom. Sines cancel, and you're left with 1. But save yourself all that rewriting and just recognize when the reciprocals kill each other. That's all I want to do there. Oh, right. We're going to see something new here. And that main new thing is a 2. We haven't had to work with a 2 yet. There's really 2 ways to go about dealing with this 2. I'll probably show both, and I'm not even guaranteeing these are the easiest or fastest ways, because there's 2 options. This is a difference of squares. It factors sine squared x minus cosine squared x, sine squared x plus cosine squared x. Yeah?
Can we change x to theta?
If you want to, yeah. Would you like me to now? Is that what you're asking? Or just in general?
Just in general.
Yeah, whenever you want to, go ahead. X, theta, a, t, all be the same thing, variable. Well, now what?
I feel like sine squared x minus 1 is something.
Well, we don't. Yeah, but we have 2 sine squared x minus 1, not sine squared x minus 1.
So you can solve that part and then,
On the right side right now, I'm not going to. Are you talking about this right over here?
and then like,
Or this part right here?
maybe going up, tangent just be cosine squared, like
Negative
2 cosine.
No. No. Because there's 2 signs. It ruins everything. This is the multiplication of 2 signs. I can't do anything with that right side right now. I could manipulate it in a way where I could, but I don't want to right now. Yeah, Katie?
So you said you can't do the same thing to both sides, but for this one, could you divide that side by one of those and divide the other side by one of those too?
Mm-mm. Come on, guys, it is screaming at you. It's just saying, please, come on, do this. Yeah?
Is it just equal sine squared theta minus 1, sine squared theta minus 1?
Mm-mm.
Isn't sine squared plus cosine squared 1?
This is just 1.
Yeah.
That one's gone. Now we have this. Oh.
Oh, that's a.
Yes, Chris, it is. And it's the one. This one you should see. This one should slap you in the face. This one you should be looking for. Okay, now I could break this down again into sine x minus cosine x and sine x plus cosine x. I could do that, but I don't want to. The reason I don't want to is then I lose my squares, and I need to have a square somewhere. I don't want to break up these squares. So I'm not going to do that last thing I just showed. What I am going to do, and this is the trick that comes from seeing a 2, I know that sine squared plus cosine squared is 1. So I can take the cosine and get it by itself. And I get cosine squared x equals 1 minus sine squared x. And this is going to go here. What that does is give me a second sine squared. It gives me 2 sine squares, and that's what I needed. 2 sine squares. But the negative gets distributed. It's a beautiful thing when it happens.
Oh man, that's gonna mess me
It
up.
becomes sine squared x minus 1 minus sine squared x, which is sine squared x minus 1 plus sine squared x, which is a beautiful 2 sine squared x minus 1. Okay, so when I see this 2, I'm looking automatically for some kind of game like this. I'm thinking about using a Pythag to my advantage to sneak in another sine somewhere. And over here, I'm going to sneak in another cosine somewhere. Question there? Okay, I think we just have 2 more. Yeah, 2 more. After this, I'll let you work on your homework. I'm going to show 2 ways to do this problem. I don't care which way you pick. Show one you like better. The one on the right is going to be the one we're more familiar with. Tangent is sine over cosine. Cotangent is cosine over sine. You need a common denominator. Now that I have a common denominator, I have sine squared minus cosine squared. All over sine cosine. I have this little panic attack when I do these. Like, oh my gosh, is this going to work out? Because sine minus cosine doesn't tell me anything. Sine squared minus cosine squared is not any help. But I remind myself that I need to get two cosines. So I'm going to take sine squared and turn it into 1 minus cosine squared. Gives me this. Well, now I have 1 minus 2 cosine squared over sine theta cosine theta. That's what I wanted. Okay, question about that? Let me show you the other way also. So here's the old way, which you probably can't read anymore. And here's the new way. Stop that. Good place. I can take 1 minus 2 cosine squared, I'm going to put it to the left side now, and turn it into 1 minus cosine squared minus cosine squared. I can split the 2 up into 2 separate ones. Make 2 subtractions. 1 minus cosine squared minus cosine squared. Well, 1 minus cosine squared right here, this is sine squared. This is the same as this. And then the sines cancel on top, so this is tangent. And the cosines cancel top and bottom, so that one's cotangent. And that's what I wanted. Yeah.
Is this kind of just trial and error? That's kind of the trust and just on the first one and then the 2 showed up.
Yeah, it's trial and error.
Are there any hints that can help us?
The biggest thing that I've given here is if you see a 2, you know you're trying to sneak in a second sign somewhere. So take your cosine and turn it into a sine. Oh, I wanted 2 cosines, excuse me. So take your sine, turn it into a cosine using Pythag. Or take your 2, split it up into 2 different things. And so whenever I see this number 2, I know I'm doing one of those 2 things. And if you look closely, you'll see that my blue steps going this way are really just my orange steps going this way. The complete opposites of each other, which I think is kind of fun. That's really what happened. Any other questions there? Okay, last one. Would you like to try this on your own for a bit, or do it together? Okay, let's try it on your own. I'll leave this last one up here if you want to look at it. Chase is asking, is 1 plus cosine squared x an identity? Well, if we take sine squared plus cosine squared, and we try and get this to happen somewhere, I can subtract the cosine squared, and that gives me sine squared equals 1 minus cosine squared. And then to make that a plus, I could try and multiply everything by -1. That would give me this. And that's still not the same. So really what I would have to do is something kind of crazy like this.
You're doing the same thing to both sides.
This I know is true. Since I know the identity is true, I can. I don't know this is true, so I can't. That's the difference. But you're going to see this doesn't actually help us at all. Because now we have sine squared plus 2 cosine squared equals 1 plus cosine squared. So I could plug this in for this, but what does that do for me? So, to answer your question, no. The 1 plus cosine squared, I can't make that a useful identity.
So folding, that's not true.
Foiling is a very good option. You can also start with the right side. But on the left side, foiling is a great idea. But I'll let you keep working for a bit. So one thing that's been suggested is foiling. When I foil, I get 1 minus cosine to the 4th of x. I'm not going to actually foil that out, that's what you get. Well, that's the same as 1 minus cosine squared x squared. Okay, does that make sense? Do we see that? Well, 1 minus cosine squared x is really 1 minus sine squared squared. Took cosine squared and made it 1 minus sine squared. And then 1 minus sine squared becomes 1 minus 2 sine squared plus sine to the 4th, which is then positive 2 sine squared x minus sine to the 4th of x. Yeah, Katie?
Is that like from log where you can make the exponent the coefficient?
Kind of. It's sort of the same idea. Yeah. Now, I think that's the worst way of going about it. It works if you can follow this foiling. I actually had to foil this guy right here. This got foiled. What's better is to take your 1 minus sine cosine squared and make it a sine squared. Take your cosine squared x, and I want to get another sine out of there. So make it 1 plus 1 minus sine squared. Now I have sine squared x times 2 minus sine squared x, which is 2 sine squared x, minus sine to the 4th of x, and that's what I wanted. That's the better way of doing it, but they both work.